Hello everyone. Great to see you here today in this small group of great people that are trying to change the global vision of humanity. My name is Dima Chizhevsky. Today I will try to serve you as a discussion moderator, and I have several proposals for you in terms of this initiative. First of all, I should say that in the global vision of this call and of this call as first of the series of consequent calls, we're trying to begin the process that maybe each one project in industry is trying to do, maybe is talking about, and to initiate a global open-minded community of people who are working in a layer 2 related projects with a focus on maybe sharing scientific information and trying to keep this kind of information and researches and maybe some community activities reachable by each one of people who has internet, maybe. So one another moment, I should say you that we want these calls to be open and accessible by each one people who wants to access it. So for those of us that have no possibility to join at the moment, we are recording this video. So I believe you guys agree with that. Okay?
Yeah.
Cool. So I propose to begin with maybe short introduction of each of us, and I believe that no one could do this better than each one to introduce yourself. So I will begin. As I said, my name is Dima Chizhevsky. At the moment I'm working in GEO protocol. It's a layer 2 solution that tries to make transferring assets as simple as maybe transferring text in internet. And as each one project in this area, we're facing the same problems that are related to routing and maybe some other approaches. So at the moment, our project, the team of project consists of 20 people, and so yeah. So who wants to continue, guys?
I can continue. I'm Dominik Schmid, and I'm working at the Raiden project. And for the last half a year, we tried to implement the first routing system that we can call it like that. And I did it together with Karl, and Karl is also here. So you want to listen in. And we had some problems, and we had some solutions and some design decisions on that, and maybe we can provide something.
Yeah, so that also explains my role here. I'm Karl, also on the Raiden team, so I don't think I'll have that much to add.
Okay, thank you, Karl.
Hello, I'm Pedro Moreno-Sanchez, and I'm a postdoc now at TU Wien. I've been working since I started my PhD in the security and privacy of credit networks, and now more recently also in the Latin network. And a bit more concretely, actually, we are interested in looking at which are the fundamental security problems that we have with the current way of doing multi-hop payments, and also routing algorithms in general in this type of networks. And also we have several works on the privacy aspect. How can we, so with that information that is actually being leaked today in terms of topology, payment values, who is paying to whom, and how we can actually improve on that. We have results that we show that the current payments using HTLC can lead to some security issues, some problems. Also, that the current payment algorithms in the Lightning Network have some privacy issues as well, and then we propose cryptographic protocols that can be added as an overlay to actually solve these problems.
Okay, thank you for introduction.
Yeah, I can go next, I guess. Hi guys, my name is Patrick McCorry. Like Pedro, I've done research in this area for a few years. More recently, I founded a startup called PISA Research that tries to solve the underlying problem for all off-chain protocols. So off-chain protocols tend to assume that the user is online and synchronized with the network. If they go offline, they're at the risk that they could lose their money. So at PISA, what we want to build is an accountable watchtower, in the fact that we can be hired so the user can go offline. If we cheat the customer, they're always guaranteed either a refund or we get sloshed. So we're financially accountable if we're hired, and we just protect the user while they're offline.
Sounds really great. Okay. Cool. So now seems that we are ready to...
Sorry, new computer. I hadn't installed Zoom yet.
Stefanie!
Nice to see you here today with us. Hello.
Hi.
I'm Dima. Actually, we already started our call, but
Sure.
We're happy to see you here today. So, first of all, I should apologize for my non-native English, but I believe you are okay with it because
I think Patrick is the only one here with native English, right?
Well, I'm sort of broken English.
Yeah.
My accent's too strong.
So actually, at the moment, we have introduced ourselves to each other and have covered some several organization moments. And I propose you to introduce yourself to us because no one can do it better than you. And okay, so.
Okay, hi, I'm Stefanie. I'm working at TU Delft as an assistant professor, and one of my areas of research is second layer solutions, in particular routing algorithms in these networks. And yeah, I'm one of the main developers together with Pedro of the Speedy Memos protocol. Yep.
Cool. So sounds really great. Are you a software developer or you're?
I'm a researcher mainly.
Okay. Okay. Thank you. So seems that we are ready to move to the discussion itself. So I have prepared the next plan for our today's call. How do you guys looking on the idea to have a short talk about two key advantages and two key disadvantages of routing approaches that you have implemented in your project, or maybe you are trying to implement or have covered by some research? Because I believe that in case if we have answers on these questions, it would be a great basis to have a more wide scientific, strict talk. Okay. So to not keep in accordance to best practices of decentralized community, I propose to someone who wants to be the first.
I can probably jump on. So I think
Thank you.
as Stefanie mentioned, I'm one of the creator and developers, creator of the Speedy Murmurs. So one of the main challenges, or one of the main problems or challenges that we found with the current routing algorithm in Lightning Network, or the payment channel networks in general, is that assumes that there is a public topology, or the sender might have a pretty good view actually of the whole set of channels, or at least a subset of all channels that are actually in the network. Which, well, this makes it efficient in practice. Maybe it's obvious that there are some privacy issues. Maybe you don't want to leak with whom you have some.
Can you specify these issues for us?
The privacy issues. So, I mean, the one, for example, is that if you reveal your link to somebody, you are revealing that you are having actually economical interactions between them. So I think a practical example would be company X revealing that has more economical interactions with company Y. And the other thing is it's also go a little in the line of scalability. Sense that you can have a view of a network that is of some medium size, but as the network actually grows in size, it's less likely actually that you will be able to have a copy of the whole network, and more if you go to small devices like phones. So what we tried to do with speedy marbles was, I think one of the advantages of speedy marbles would be that you no longer need the view of the whole network, but more like what we call the local view, actually, which means that you need to know neighbors that you have and how to route to certain nodes that are called landmarks, how you can do that.
Okay.
So yeah, basically, I think this is one of the advantages in comparison to what is being developed so far in the routing spectrum.
And how many intermediate nodes your routing algorithm can support? I mean, in case if one node tries to find paths to another node, how many intermediate nodes can be found? Max amount of intermediate nodes between two nodes.
Theoretically, it's infinite. So there is no upper limit. Obviously, there is a problem if we reach a point where the longer the path is, but that's the same in the networks at the moment. The longer the path is, the higher the probability that at least one link cannot sustain the payment because of a lacking balance.
Okay.
But that's not directly related to our routing algorithm. That is just parts of what the network looks like. The more links you have, the higher the probability that something will go wrong.
Agree. Totally agree.
Eric.
Okay, thank you. Who wants to continue?
I was just going to say that there's also the problem of fees. Is that I mean, you have to pay every hop along the route, so that sort of determines your maximum offline.
Yes, but that's also not a problem that is specific to any routing algorithm. It's a generic problem. How do we deal with fees? How large will the fees get? But
in my vision, with significantly long paths built by routing algorithm, we are increasing the probability of combinatorial. Sorry, one moment. I will try to find this term in English. Yeah, combined explosion. No, in case if network has one moment. In case if each node in network has significant amount of connections to other nodes and the whole network is well connected, is this a problem for routing?
I think I get what you're saying. You're saying that at every node on the path, that if I need to consider all possible combinations of paths, then these will be too many to consider.
Yeah, yeah.
This is not the way our algorithm works. It makes essentially a greedy decision, which might mean that at some point some very weird path might be missed. but that's sort of a compromise. So what we're doing is essentially nodes get some indication. Okay, actually, let's go one step back and say that our routing algorithm works in two phases.
Okay.
The first one assigns network coordinates, so some sort of identifier to each node in the network.
Okay.
And based on the coordinates, you can say, these one or two of my neighbors can offer me a path to the destination. And then I can only need to go over the node that offers me the best path at this particular moment. And I can disregard all my other neighbors. That means essentially in each step, you only have one choice to make. And this is why there is no combinatorial explosion, because we really have these coordinates that already tell us on one specific point, you have to go to this neighbor because that is the one that based on its coordinate has a connection to the destination.
This approach looks for me as the main approach of BGP routing. No?
It is very similar in the sense that we're working with coordinates. What is different to BGP is BGP essentially gives you a global view, right? So every autonomous system will broadcast values. In this case, we only get information about our direct neighbors, which is good because if we really try to get information about all of the participants in the network, that's again in a dynamic network, it's quite easy that quite likely that information will be outdated at some point. But it's the same type of idea. You get some information that can be used to construct paths to the destination, and then you can make your decision based on this, without having a complete snapshot of the network.
Okay, so I believe I got it. Thank you.
Okay, cool.
One thing I like to ask actually is what I sort of notice in practice is that a lot of people do source routing, like Lightning and Raiden, but then academic papers seem to focus on per hop routing. Why do you think that distinction is? Why are they not building the per hop routing protocols? Did that make any sense? Or
You mean the why?
Are you asking me?
Does anyone? Yeah, I'm just doing that. I guess you and Pedro
why people are not looking at the source routing protocols in academia? Or?
Well, like my understanding is that like in Raiden and Lightning, they've done source routing, whereas the node, I pick my path in advance and I send it. But in like Silent Whispers and Speedy Murmurs, it seems to be per hop routing. Maybe I've got confused. That seems to be the distinction I've seen. I don't know why there's a split.
In Raiden, we just implemented source routing today, like it's highly undeveloped branch. But before that, we had these hop routing actually.
Oh, really?
And always routed back. Yeah. But our plan is to include onion routing. And as a precondition for onion routing, we think we need source routing.
Okay.
Does that make sense?
No, yes, that makes sense. I'm only not sure if... let's do it differently. Why do you want to have onion routing?
We think it's more privacy preserving than our current approach.
I don't necessarily agree with it.
Yes, that's interesting. Yeah,
And no, the reason is that onion routing, as it is implemented in Tor, is more privacy friendly. That's indeed the case. However, usually it's not, you don't have the Tor case. An important property of Tor is that it selects the relaying nodes randomly from everyone who is in the network, which of course you don't do because you're out based on existing channels. So you do not get the guarantees that Tor has. It would be interesting to look into what guarantees do you get that are better than if you don't have it. I don't have a concrete answer, but it's not the guarantees that Tor has for other honor and routing protocols.
Yeah. Like at the first step, we also had an economic approach on this, because at the moment for every route we pay a small fee. Like we can request routes on our landmarks. We call them pathfinding service. And whenever you request a route, the pathfinding service basically keeps track of the global state of the network, or of parts of the network, right? So it tries to keep track of the capacities, and then you can request this landmark for a route, and then you pay a fee. And when you make hop-based routing, basically, then you would need to ask with every hop the PFS, or you go with a local channel state, and that we thought might be less efficient and more expensive, and that's why we included permissive source routing now.
You can be right on that our algorithm does not always guarantee you the cheapest or shortest path. It's relatively close, but because we're making this call of not wanting to save the global snapshot, we cannot have global optimality. That's
totally agree. Yeah.
So.
Yeah, actually, we looked at speedy murmurs together here in the project 3 weeks ago, I think, or 4 weeks ago, and discussed it. And it would look really interesting, actually.
And also one thing regarding source routing is that we're not running the whole routing on each of the nodes, but we have a separate pathfinding service which does the actual routing. And if you start doing that, then you have one node, one service, which can use up huge amounts of resources to build a mostly global view and do complicated routing. And then if you do that, it makes sense to follow that route, as the single nodes won't have as much of a good network view as the pathfinding service.
You don't get any privacy if there's a pathfinding service.
That's a good question.
It is, of course, a huge limitation regarding privacy. Yes, it is.
Also security, I would say, because you're now having a central point of failure, right?
No, you can have an arbitrary amount of pathfinding service, so there is at least not a single point of failure, but of course it's less redundancy than having every node. But the plan is that there are sufficiently many that this won't be a problem. But of course, yes, it's a limitation that way.
And this is actually, like, maybe we don't come from academia at that point, maybe to emphasize that. Like, we wanted to have at the moment a system that works and is sufficient, but we are very happy to discuss this and enhance it and implement better routing algorithms and better systems in the future. But I think, yeah, our system now is not very privacy preserving, and there are single point of failure. And that's why we are looking at all these papers, like, for example, Speedy Murmurs or Flare, or also the Cellar network routing system seems to be really cool. But yeah, at the moment, there's no algorithm we can implement right now that fits our requirements.
I would actually agree with you. There are a couple of open questions for each of the algorithms, which I think would also be my answer on why they are not implemented. Source routing, in a way, is simple, or using one of these routing services. There are a lot of conditions going into the per hop routing. So it's more complicated, and you have to actually do proofs. And even with Speedy Murmurs, there are some things where I would say we at least want to improve upon it. In particular, but source routing doesn't do that either, but Speedy Murmurs has a problem of keeping channels balanced in certain situations, which is what one of my students is working on, trying to make it better. And it's not, in the way we designed it, it wasn't really designed so much with one specific system in mind. It's a more generic approach. How could we look into this type of networks and what would happen?
Yeah.
We also did not really consider fees. So.
And this is like something we would love to look into more in autumn, or like August or September. How speedy members could work with this hash time locks, and when you consider the time or the locked amounts, when you have these many payments in the network, when you do it per hop routing, then there's always a lot of capital locked, right? If one hop fails and then we need to send it back, and so I don't know how, like, we wondered how efficient it is when in a real system then.
Me as well, which is why I have a student implementing it in Lightning at the moment, and he takes care of the whole looking into hash lock contacts and how it relates. He's at the moment still working on the implementation, but he should be done by end of August. So.
But it would be really nice if you can share these results with us.
Sure, he's also very excited. I was considering if I want to invite him to the talk, but I had the feeling that this talk is more generic one, and he works on a very
you can invite any people you believe.
Specific problem. But if there is interest in what exactly he is doing, then he's very willing to share it. I mean, that's the sort of was the goal, that at the end we have something that's not only an academic project, but that actually works and addresses some of the engineering problems that show up when you actually have to deal with integrating it into a system and dealing with fees and other aspects.
Yeah. And maybe like what I have, like since some weeks it's bothering me, and maybe that's more a question for academia. Like I think, isn't it when a routing algorithm, is there the tension that you cannot really solve between efficiency and privacy? Like, wouldn't it be the most efficient if you don't care about privacy at all and you have this one entity that knows the global state and just makes it Dijkstra, or like the fastest k-short path?
I would say that this is not the case. I mean, the routing of a network, as you can imagine, is just a problem that has been there for many years. Is take a route and find a path between two nodes. For example, another setting in which we have studied that is in credit networks, because like a Ripple or so, where basically you have the same problem. You have a bunch of nodes where every node is an account. You have to find a path of credit between them. So we have a work, and there are many other works in academia, that the first approach that they look at is what you are guys doing. They take a server that has the whole view of the graph, but they obviously leak private information. So there are privacy techniques that allows to have like an encrypted version of the graph in the server. The server computes a path over the encrypted graph and gives the encrypted result, which is encrypted path, back to the client. Now the client can see the path, but this is information that he should know anyway to do the payment. While the server doesn't learn who was the client, what was the path that was searched, who is the sender, who is the receiver, and not even what is the length of the path. So there are techniques like ORAM or fully homomorphic encryption. There are many of these cryptographic techniques that you can leverage even in the setting that you want. So you can have a single server where the server does a computation or encrypted data. The server can prove actually that it's doing the correct computation. You can prove to the client, I don't know what I did, but when you told me to do it, it's actually correct. And the encrypted result is given back to the client opens the result, is happy, and do the payment. So I think there are techniques actually to have to solve this tension that you
okay. I just want to take notes. So the protocol was Aura, or how did you call it?
The protocol we have, the paper that we have is called PRIVPay. It's called Privacy Preserving Payments for Credit Networks.
Oh, okay.
And there we cite a bunch of other papers that also look at this problem and give different approaches in which you have trade-offs of, obviously, between the privacy and efficiency. Then saying it's possible to do.
I mean, even if you don't consider privacy, there are always trade-offs in routing. One of them is simply, very often, the more information you send around in the network, the shorter will be the path that you find. But on the other hand, you then have the information that is sent around. You have the overhead of getting information to everyone. So that's not even a privacy-related trade-off here. That's just a generic routing trade-off between one type of efficiency, that is how long is the path that we're using, and another efficiency metric that is how much overhead do we create. And those are to some extent at odds as well. So privacy and efficiency in the terms of shortest path are not the only two metrics that can be satisfied and are sometimes to some extent contradictory. So it's a little bit more complicated.
Is this approach applicable for fast-changing networks like mobile networks?
Our approach, like speedy murmurs?
Yeah.
I haven't tested it in mobile networks. It's better for fast-changing networks than it is for source routing. I have tested it for fast-changing peer-to-peer networks like the Freenet network that is relatively unstable, and there it works. I have to say at some point it will likely break. So if you really have something like a mass join or a leave, so if something happens like, I don't know, half of your network gets lost suddenly and then rejoins slowly, all within like 2 minutes, but all are in different positions, there will likely be an issue. But I don't know any system that will not have an issue with this. Generally, we can deal with changes very, very efficiently. There's something in the paper on speedy murmurs about how many messages we need to send if there is a change to the network. And usually it's only like, if a new node joins, it's usually only like 1 or 2. If an old node leaves, it's about 4 to 6. So it stabilizes. So there's a lot of, so it can deal very well with this type of leaving and joining nodes, as long as it is not everyone joins at the same time.
Okay, thank you. Have you maybe researched some points about what if some node in a network tries to spoof the information about its neighbors, or maybe some change its code and change its protocol and try to maybe play malicious role in this algorithm? Is it secured for this kind of activity in network?
Partially. I mean, you can never fully prevent a node that will simply drop every information that it receives, I guess. But that would be the same in source routing. So if someone just does not execute a payment, then there is an issue. And you have the same issue for speedy murmurs. If it's concrete about sending incorrect information to your neighbors, you can do so and you can confuse them. But we tested it, you can overcome that to a certain extent by adding redundancy. So instead of nodes have these coordinates in the system, and what you can simply do to get a certain degree of security is to have several of these coordinates that are built in different ways. There's some randomness in the selection of how you choose them. And in a lot of cases, if you just have multiple of them, you can be sure that at least one of them works.
So it seems logical for me that these kind of algorithm are relying on some kind of solution that spreads the IDs in the network. If I am a new node, how can I get my ID to be a participant of this network?
The key idea is that you communicate with your neighbors, and they have certain information about their IDs. And you can adapt yours based on your neighbors. And here the interesting aspect is now, of course, if one of the neighbors gives you wrong information,
okay,
then you might end up with wrong information. But if you use multiple coordinates and use a different neighbor for each of them, then you only have at least for one coordinate correct information, unless all of your neighbors are malicious. And I guess in case that everyone around you is misbehaving, it doesn't really matter which protocol you use. You're probably screwed with all of them.
Okay, agree. Yeah, thank you.
Okay, good.
We have in our simple implementation with the pathfinding service, it's always that the two nodes, the two channel partners, they send updates to the pathfinding service individually, like updates how the capacity looks like. And if this does not is not consistent with the information in the smart contract, then the pathfinding service always takes the minimum. Or if a node decides not to send these updates because it wants to stay private and want not to mediate, then the pathfinding service would always consider this channel with zero balance. So in that case, you can, like, they can send wrong information, but it will never lead to a higher wrong view in the wrong direction. Does that make sense?
Oh,
so
yes.
the pathfinding service will never consider a higher capacity than there actually is. It would just be smaller.
So essentially, it's like you try to make sure that it never happens that anyone gets information that might lead to a failure afterwards.
Exactly,
Right.
but like there can be a failure, like in the route, there is enough capacity when the PFS, like the pathfinding service sends the route, but when you start the payment, then something can happen, obviously, and then you have the backtracking as well. But at least for when computing the route, we make sure that the path has enough capacity according to these capacity updates.
So essentially, you're avoiding false negatives.
Yes.
But you might then actually have false. Well, you might actually have the case that if someone just does not report their value, then there might be a path, but the pathfinding algorithm does not find it, right?
Exactly. But this is like the rationale behind that is when a person does not report the capacity, then it does not want to advertise for mediating, right? So if I want to stay private in the network, then I just make this PFS mode off, which means then I don't want to earn fees in mediating. But when I want to earn fees mediating, then I would be happy to advertise the balance somehow. So this is the rationale behind it. And when just one channel partner decides not to mediate, but the other channel partner wants to mediate, then we obviously go with the one that does not want to mediate because.
Sure.
Yeah, exactly. But this is, again, this is the most pragmatic way we found to implement them.
No, I agree. It's clearly the sort of the solution I would go with if I had to implement something. It had to be on the safe side, and yeah. So.
Okay.
But I've maybe another question that interests us a lot, because we have the feeling that in all these payment channel networks, especially like Lightning or Raiden, and maybe even in state channel networks, the problem is that over time, channels will always be imbalanced. And therefore, you would need to find smart routes that serve the greater good to balance or rebalance the network again. But for a longer route, you pay more fees, right, per hop. So the question is, how can you design a routing algorithm that kind of balance the network, considering mediation fees per hop? Does that make sense, the question? Or
Yeah, the question makes sense. We thought about that before.
Yeah,
This is a really hard problem, isn't it?
Yes, we actually having had two ideas. One is doing, as you said, finding a routing algorithm that sort of optimizes between all of these properties. Another one was to have a separate rebalancing algorithm that
Like
finds
rewrite?
circles in the graph. And
Like
if
this
you
rewife.
yes, but revive cannot deal with like, yeah, it's like revive, but revive has sort of the central point and only does it with 3, right?
Yeah, but when you have another one, then I would be happy to read it.
No, we don't have one, but we would be interested in one. One of our key challenges here is, as you said, fees.
Yeah.
If you have this circle, people might still take fees unless all of the nodes on the circle agree that it's to their best
Yes.
to change the balance. But then you have certain restrictions on the type of circles you can find. Because as soon as one node in the circle says, but for me, rebalancing doesn't make sense, they will not do it unless you pay them.
Yeah. Yeah,
So,
Karl actually came up with a very nice idea of negative mediation fees, which means you can, like for a greedy node, you can rebalance your channel and pay someone to route through you. And then you need to, like, this is also, we go with that now as a first implementation. Like with per channel, you set the fees, but they can also be negative, and then you pay for, Yeah, that
would be interesting. I should have someone have a look. We had one of the students who was really interested in looking into he's a bit into game theoretical models on how to choose fees and stuff, aspects like this. And he was looking into these networks and looking at how do I choose my fees from a game theoretic perspective. And he also came up with the case that sometimes if you take rebalancing into considerations, choosing your fees negatively might be interesting. So I should point them to you when you're actually doing this.
Yeah. Maybe
telling him that there is an example where it is done.
Yeah. Maybe you can elaborate a bit on this, Karl. I don't know if it's interesting for you.
Yes. So we thought about that, and actually by not having just some fixed mediation fees for a channel, but having fees which depend on the current state of the channel, you can actually incentivize moving towards certain channel states. And if you do these fee schedules in a nice way, then just by having the routing algorithms choose the cheapest route, that will help you balancing the network again. And some people might even look for certain circles in your network where they can send a route and get money back. Well, okay, currently we won't support anything where you get money out, but at least where you can send payments for free because the negative mediation fees will eat up all your other fees. We wrote a few lines down on what we plan to do and why we think this is a good idea. Nothing as thorough as a scientific paper, but I can post the link.
Yeah, that would be great. I'll have a look and I can forward it to the person who's really into doing this sort of things from a scientific perspective. If he has any questions, I would put him into contact with you. Great.
Yes. Or also, if you have any feedback.
Sure.
Or if he finds the loophole.
He might just do that. He's a security person. They always find loopholes.
I wanted to add also, actually, I mean, we were looking also at this problem of rebalancing in our lab, but more from the perspective of how we can solve the problem of atomicity. In the sense that, imagine the nice case in which there is a group of users that they form a cycle with their channels and they want to do rebalancing. So they have agreed that rebalancing. But you make sure that either all of the channels get rebalanced or none of them get rebalanced. Like, it should not be the case that you find a cycle, then the first k channels get changed into the rebalanced version, and then the n minus k gets not changed. So we call it atomic multi-channel state. Atomic multi-channel update. And I can put the link to the print papers. We have like a first draft of it. And the nice thing with the thing that we observed is that by having this multi-channel state update, so basically you can have any set of channels. They don't need to be a cycle in principle, could be any set of them. You can really have a protocol in which, as soon as you have one honest user, not all the others could be malicious, you can have a protocol in which either all the channels go into the new state, and this state could be the rebalances of some the rebalancing of some links, or just a payment between two nodes, or we also see a use case to be crowdfunding, for example, and you have end payers and they want to pay to a receiver, and you want to be the case that either the end payments go through, so either really like the end users pay to the receiver, or none of them contribute any balance. I think this is actually a good, there is some use case for this approach. And the other thing that also, when you have this atomicity, this way of doing multiple changes atomically, you can reduce the collateral, which I think is another main issue that we have in routing algorithms today. Like the fact that the first link in the payment has to lock coins for a longer time than links later in the path. So the first one has to lock coins for a really long time. So we observed that theoretically actually it's possible to have a protocol in which you have many changes in a path, or in a set of channels, in which you lock the same amount of coins in each of the links for the same amount of time. And still secure, like nobody will lose coins if one try to close it before or whatever. Just wanted to mention that maybe it's also a use case that would be interesting to discuss, or some properties that might be interesting for routing or for balancing in general. Just I heard was the topic now.
Atomicity you're talking about is one of the main concepts of the project I'm working on. And in our team, we have separated these things. We have separated the routing problem from the atomicity problem. And at the moment, we have three separated algorithms for routing, for cycles discovering and clearing, and the payment algo that implements the atomicity you're talking about. So in our approach, we're achieving this kind of atomicity by collecting cryptographically proved agreements of each node that takes part in the operation. So commit this operation in case if all other nodes are agreed to do the same thing. It is mathematically complicated a little bit, but at the moment, we believe that we have a strong mathematically proved algorithm that solves exactly these things. So if you want, I can share it with you, and I would be happy to yeah, and I would be really happy to receive maybe some kind of feedback from you. Or maybe reviews.
Like that, or so that we can take a look. I will definitely take to the members of this project, and it will be super nice to see, to check.
Okay, I will sign these documents for you. Okay. So, seems that we're running out of time. I have one more question. So, all of you, I believe that in terms of best practices of decentralized communities, we should agree on who will want to be a moderator for the next call, and so prepare the next subject for the next call. I believe that these roles should be transferred to the participants of our community. What do you think?
I think it really depends on the topics. I think depending on what is the topic of the next call and who are the set of participants, I guess some person might feel more, it would be easier for some person to be the moderator because has more experience or feel more comfortable. Okay. Maybe we could do it then more ad hoc, depending on when the next call is, who is available, and what is the topic for it, I think.
Maybe let's do monitoring. Maybe Patrick can moderate.
No, I just gotta point it. Yeah, sure, I can do that. And the next one.
Cool. Thank you, Patrick. So, I believe that the cooperation and coordination should be continued in our Telegram group. And thank you guys for joining. And I believe this call was really cool and really valuable for each of us. For me, it exactly was valuable.
Okay, that's good. Yeah, it was fun to talk to and figure out what all of you are doing. And thanks for the links. It will be
Thanks for
helpful.
organizing, Dima.
Yeah.
Thank you for the call. It was nice to talk to you guys.
Thank you very much, Dima, for moderating.
Yes.
Thank you for joining.
Bye. Enjoy your weekend.
Bye.
Bye to the next call.